at the end of the day, the simplest way to describe it, it's like technology based on biology. It's like molecular or cellular processes that turn into product to improvement the life of people. It can be in cancer, Alzheimer, and so forth. And I think over the past thousands of years, you have also seen there have been a lot of biological tasks being executed by human. Bread is another example, but I think now in the fourth industrial revolution, we are just at the next stage where we are going. And a good example, therefore, is also when you look into orphan diseases. This is also a place there have been huge developments over the past couple of years. I don't know, does someone of you know about orphan diseases, what that is?
Orphan diseases? No? No, you can explain,
I think there has been a big push over the past couple of years from regulators and politicians globally. It's talking about rare diseases. The definition in the US, for example, is when there's only 1 out of 200,000 persons affected, or less than 5 of 10,000 in Europe. And based on the limited leverage you have for such products, there's now a push in granting pharmaceutical companies extended patent protection, for example, or shorter review periods. The companies are also incentivized to dig further into that field. Sarepta is a good example. You might have heard last week. Sarepta got approved in DMD, that's Duchenne muscular dystrophy. Boys are affected from this, like shrinking muscles, ending up in the wheelchair in their teenager age, and really poor suffering for them. But I think this exactly explains in what direction we are going when talking about orphan diseases, for example.
So, but why can biotech help then instead of, let's say, other traditional pharmaceuticals? What's the difference then?
I think at the end of the day, when you look at biotech and compare what it was before, I think historically there have been like a chemical-based treatments in pharmaceuticals, but at some point we have reached the limits there. And by reaching the limits, when biotech came in, I think with nowadays computing power, there's a much bigger ability in what you can proceed, how you can analyze technological changes, and therefore biotech has become much more important. There has been more innovation going on based on the computing power, but also diagnostics in the space that helped a lot to have more efficient processes around these.
All right. So now the biotech fund. We have 2 minutes left. You are managing the UBS is managing the biotech equity fund. How do you select winners and losers?
I think that's the 1 million question at the end of the day.
Even when more than that. More than 1 million, yeah.
If you're able to select the winners from losers, I mean, this is quite difficult if you talk about an industry where there's huge risk associated with every single clinical trial. Therefore, on one side, diversification is a big driver and important to have in the portfolio because you can't put all on one card. On the other side, I think what is also quite beneficiary to the industry is when you see the development, and we have already heard before, that large companies, it's more difficult to invent. And therefore you have all the small mid-cap companies in the biotech sector that come up with very new approaches, and then at some point, large pharmaceutical companies kicking in, taking them over, and you as a biotech investor can benefit therefore from a takeover premium, and also the risk is transferred to the pharmaceutical company for the rest of the development stage.
So you're looking at small to mid-size companies then?
I think at the end of the day, it's always the balance. You can have some really speculative small and mid-cap portfolios, but on the other side, you also need some more stability in the portfolio. Larger companies, therefore, earn cash flows themselves, so there's less risk of refinancing if a trail files. And so I think at the end of the day, it's a balance for both to be successful with.